This is called the Devious Pythagoras cup. Now a name like Devious Pythagoras cup might sound redundant if you know what a normal Pythagoras cup is. This is a normal Pythagoras cup. It looks like a cup with something coming up the center here. Now you can fill this cup up like normal and drink from it, but if you get greedy and fill it up too much, then it drains the entire cup. This cup works by using the siphon effect. There's a tube up in the center portion here, and when you don't fill it too high, it doesn't reach the top of the tube. And you can use the cup normally. But when you fill it too much, then it reaches the top of this U-shaped tube and creates a siphon that empties the entire cup. The legend goes that this cup was created by Pythagoras around 2,500 years ago in order to punish his peers who were too greedy and overfilled their cups of wine. This is why it's also called the greedy cup. But now let's look at the Devious Pythagoras cup. Notice that there's no center tube area here. Now I can fill it up with a modest amount of liquid and it doesn't empty. But watch what happens when I get greedy. So now we have more than enough, we don't want to get greedy, but if we just want a little bit more, watch what happens. Well, we know that there has to be some siphon effect going on here, but where? Well, it's actually hidden in the walls of the cup. It's gone. I have a half version of the cup here. So as the water fills the cup, it fills up here, reaches this level, and then it reaches this tube that goes up and around to this side, and then it starts flowing through this side and comes out the bottom. So then it creates this siphon effect that pulls it all around and out the bottom. This is such a better version than the standard Pythagoras cup because it just looks like a normal cup. It doesn't look like you're drinking out of some weird object with something in the center. If it's so cool, why wasn't it made like this in the first place? Well, this type of design is extremely hard to manufacture and was almost unobtainable until now. But what changed to be able to make it? We have 3D printers. 3D printers are amazing at making things that would be near impossible to fabricate with other methods. So far, I've just glossed over the fact that the siphon effect works. Obviously, this effect has been known for thousands of years. But for hundreds of years, we didn't really understand exactly how it worked. For example, the traditional explanation is that gravity pulls down on the exit side of the tube. This causes a reduced pressure in the portion of the tube that's above the water level. So the atmospheric pressure pushes up the water from the upper reservoir into the tube until the whole thing empties. But if that's true, then a siphon shouldn't work in a vacuum. But watch this. It still worked. It clearly operates just fine in a vacuum. So it can't be that the atmosphere is pushing it up into the tube. But then just recently it was proposed that a siphon works more like a chain. Let's say you have a chain hanging over a pulley and one side of the chain is on a higher level than another side. So in order to get from the top to the bottom, the chain has to go up and over this, but it still works. The longer side will pull on the shorter side until the whole chain has fallen over to the lower edge. So the water can pull on the remaining water in the tube through surface tension and cohesion, just like this chain here. But if that were true, then it would mean that if there are any gaps in the line, it would stop the siphon because there's air and the water can't tug on itself. But watch this. This is called a flying droplet siphon. There's clearly no continuation of water contact between these two reservoirs, but the siphon effect still works. So it can't be explained by purely a gravity effect or a cohesion or surface tension effect or an atmospheric effect. So what's the answer? Well, there are actually contributing factors from all of these effects, and probably more. So none of these ways of describing how a siphon works are wrong, but they're just incomplete. It takes all of them together to truly describe how it works. So the safest thing to say about how a siphon works is that once you force liquid into the tube by suction or by immersion, the flow is maintained by the different fluid pressures of the tube openings. And before we end, if you're looking into a 3D printer to print cups like this, I want to tell you about the sponsor for this video, Creality. They sent me their new Ender 5 S1 printer. This is my third 3D printer and it's my favorite. It has CR Touch auto leveling, direct extrusion for up to 300 degrees Celsius printing. It also has an upgraded motion system for up to 2,000 millimeters per second squared acceleration. It's so fast. It has this stable cube frame, and the Z-axis moves down as the print builds up, which allows for very stable printing. You can also attach the Sonic Pad to this. The Sonic Pad uses clippers so that you can turn your already fast printer into lightning speed. Also, you can print from the cloud and watch your prints update in real time. You can even calibrate your printer's vibrations so that you get near perfect prints. If you want to check out the Ender 5 S1 with the Sonic Pad, you can click the link in my description. And by the way, I didn't design the cup in this video, I got it from Thingiverse, and I'll put the link in the description for this cup as well. So once you get your new 3D printer, you can print it. And thanks again to Creality for sponsoring this video. And thanks for watching another episode of the Action Lab. You can head to theactionlab.com for new Action Lab gear and experiment boxes, and even some new Christmas ornaments. And thanks for watching, and we'll see you next time.